Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
29.20. So we want to determine the range of wavelengths where silicon is transparent, given that its gap energy is 1.12 electron volts. And then given that glass is transparent to visible light, we want to find the minimum possible gap energy for glass. And the hint tells us that a photon has to have less energy than the gap energy in order for the material to be transparent to a photon of the given energy. So it passes through the solid without being absorbed, because if it has an energy equal to or greater than the gap energy, it starts exciting electrons between the bands, and so it gets absorbed. So we want to figure out the shortest wavelength for which the corresponding energy is 1.12 electron volts, and then any longer wavelength is going to, or silicon will be transparent to any longer wavelength. So we'll have the gap energy here is going to be the energy of the photon with the minimum wavelength. And so then just rearranging this, we'll find the minimum wavelength is just going to be hc over the gap energy. And so this is 1.11 micrometers. This should look familiar from problem 18, because it's sort of asking the same question in a different way. And so it's going to be transparent for wavelengths that are longer than this. And the portion of the electromagnetic spectrum where this wavelength lies is in the infrared, which is why silicon is opaque to visible light, and so you can't see through it. Now for glass, the gap energy, which is now what we want to calculate, is going to have to be greater than the energy corresponding to the minimum wavelength we want. So that's going to be the energy of a photon of that wavelength. And the minimum wavelength we need is 400 nanometers. That's the highest energy photons of visible light. And so the minimum band gap that glass would have to be transparent the way it is 3.1 electron volts. So you can see that's quite a bit bigger than the gap energy of silicon. It's almost 3 times as big.